Oh, well, thank you. It's really a pleasure to be in a room presenting to people live again. It's been great to be in Perth the last couple of weeks and, enjoy the weather in the city. We've been in Fremantle. So I just want to do a quick poll here. So who in the audience here is, heard of SpaCy? Like hands? Yep. Okay, and how many of you have actually sort of used it, at least for a toy project or if not at work? Okay, cool. So, reasonable penetration there, and I'm sure that the audience at viewing this will have this sort of distribution as well. So I'll pass it over to Ines, who will go through the intro part.
Yeah. Hey again. It's nice to be here in person as well and online. We're going to be talking about SpaCy and especially in the new upcoming version, SpaCy 3. SpaCy is an open source library for industrial strength natural language processing in Python. And we've been very pleased to see the library grow over the past couple of years since its launch about 5 years ago, or maybe a bit longer. And one thing that SpaCy has always done a bit differently from other libraries is that we've specifically designed SpaCy to be used in production and to be used in industry projects. That's kind of the history. SpaCy was started by Matt when he was working at academia still and people wanted to use his research code. And there was not really a solution for that. So, which also means, the production focus also means we've been focusing on slightly different aspects of the library. And for example, we make sure that SpaCy is cheap to run, it's easy to use, easy to get started, but also very powerful. We have a great big ecosystem, which we're super proud of tons of plugins and extension packages contributed by the community. And the new version that's already released now as a nightly pre-release, so everything I'm going to be talking about already exists and you can play with it if you want to. The new version includes tons of new features that will make SpaCy even more powerful, and some of them we're going to present today. So with that, I head over to...
Okay, so the feature which... Oh, I'll come in and yep. Okay, is this good? Yep. So one of the features that we're particularly excited about and has been a big development in natural language processing, it is a model architecture called transformers. And these first came in from a paper from Google Research in 2018, and they've really been setting great new benchmarks and standards of performance for natural language processing tasks such as question answering or information extraction, entity recognition, basically most tasks, translation especially, have been very good. So in the new versions of SpaCy, we were able to take these models which is the transformer module, which holds the weights for this module that really just has the task of encoding the context of a word or its meaning in a specific context of a sentence into a vector representation that can be used by other components of the pipeline. And the thing that's really useful with this in the SpaCy support for this is that you can have multiple of these pipeline components sharing the same set of transformer weights. And this means that you can have one, basically encoding representation that you calculate just once and then have that feed through all the rest of your pipeline. And that all of the other components will be able to learn to use that, will be able to train that representation so that you get good performance without having to run multiple of these encodings, which means that it's both faster and works better on, fits better into GPUs. So you can have one GPU supporting your whole pipeline. So the transformer component here supports the Hugging Face Transformers library, and you can use any transformer that is packaged for that library. So for instance, they all have names like Bert or Distilbert, Roberta, all of these sort of family of models, you can plug them straight in and use them very easily. So this really allows us to distribute pre-trained pipelines that make use of this technology and really bring SpaCy's accuracy performance close to the current state of the art, and in some cases actually a little bit higher. And So as I said, the sharing of the one transformer is a really key feature for this. Importantly, all of those components are training the one transformer. So the one transformer representation is learning to be optimized based on whatever components you have in your pipeline. So when we were designing this transformer support, one of the key considerations is giving people actually enough ability to configure the system, because for all of these machine learning things, you need to have lots of options and lots of settings for different layers and things. And this was a key part of the solution for that.
Yeah, because for instance, if you're using transformer models, you're not just working, you want to work at different levels. You want to work at like the tensor level. You want to configure the different heads. You want to really work more closer to the metal, and that's kind of an area where we really hit a bit of a limit, and that encouraged us to revisit this idea and really redesign the way SpaCy handles configuration. Because the thing is, machine learning in general, even aside from transformers on new architectures, you want to be configuring stuff. You want to configure your model architectures. You want to configure hyperparameters. You have training settings. You load stuff constantly. You have metrics, and all of that together all depends on each other. You change one thing about your model architecture, that affects all your hyperparameters. Your training depends on that. You change one variable, everything else needs to change as well. And ideally, you also want to be able to reproduce any experiment with all of this config consistently. So there are lots of problems that you typically come across. Maybe some of them you're familiar with if you've worked on machine learning problems. Here we have just a simple example of a tagger model that's configured with some settings. And one problem is, well, each of these components, if you're writing good modular code, of course also has different configuration settings that have defaults so that you can use them independently. But the problem is, once you start nesting them, as we do here, these defaults can easily become hidden defaults. Because if you just forget to pass in one setting forward to the next layer, it's using a default configuration that you might not even be aware of. You're not tracking that everywhere, and that can potentially have a really big impact. And secondly, you can easily have conflicts. If you don't pass in one setting all the way through, you can have layers that are not actually compatible with each other. So you change one setting, everything falls apart. That's pretty difficult. And finally, with that sort of layout, it becomes very difficult to swap and iterate. You want to move fast. You want to build your prototype, try out lots of different things, and that can be very difficult because every time you change one layer here, you need to rewrite all your functions, make sure your settings get passed through, or maybe you end up with these really ugly functions where some settings are only valid in some configuration. You have like 50 keyword arguments, and that's the type of thing that usually causes very hard to debug problems, and that's all the stuff we wanted to avoid. So here's what we've come up with, and here's how the final result looks in SpaCy. This is a config CFG file that defines a whole pipeline end-to-end with all settings. And as you can see here, it's quite similar to, it uses Python's config parser under the hood if you've worked with that. We've also borrowed some conventions from Tomo and similar languages. So we have these structured sections, and and we also have subsections with a dot notation. So training.optimizer is a section under training. So you can avoid a lot of this indentation and nested stuff. So it's quite easy to read. And what really sets the config system apart from other config languages, in our opinion, is that you can actually use it to refer to registered functions. So in this case, we refer to a named function in the optimizer's registry, and it will create this function for us. So we're not limited by just what we can express in this simple JSON serializable config syntax. But we're also avoiding the problem of programming via the config, where everything your program does, including conditional logic, is suddenly expressed in another language, where we're reintroducing the same problem, essentially. And what we're doing here is the config is resolved bottom up. So we don't have one function that knows all the settings, passes them down, and maybe if you forget to pass one down, everything falls apart. Instead, we start at the bottom. So here, this is just an example of something you commonly have in machine learning where you want to vary the learning rate during training. And there are different strategies for that. So here, one of them is like, schedule that kind of warms up to a certain level. And that's a function. That function returns a sequence of numbers that's then passed into our optimizer. So if you read about some new strategy and some new cool learning rate schedule that apparently performs much better than anything else, you read about that in a paper, want to implement it, you can change that function, write your own. If it does the same thing, you can use it, and you don't have to go and start at the top and suddenly change your optimizer or add more keyword arguments to your optimizer. So that's the idea, and that's how it looks. And yeah, there's some nice syntactic sugar, and we also support variables, which solves this problem of keeping your settings consistent. If one hyperparameter needs to be referenced in lots of different layers, you can do that, you define it once, and you only need to change it in one place, and you know it's always going to be reflected consistently. And so here's an example of the registered functions. So at the top, we have a custom schedule that was implemented for a batch size. Again, that's also kind of a common trick you might want to use, where you use different batch sizes. And here we have a function that we register with the SpaCy registry decorator. We assign it a name that's unique, and then we can reference it in our config. And we can even use things like type annotations to define the expected type. So here, custom functions, and the type-based validation. So we can say this needs to be a float, which is a nice new feature we were finally able to take advantage of in Python 3. And if, for instance, in your config here, you passed in a different type that wasn't compatible, you would actually see an error message, and SpaCy would immediately be able to tell you, hey, that's wrong, you probably made a mistake here, you should fix that, because that's another thing that otherwise can really cause you a lot of annoying debugging time. And with the config and the registered function system, it means we can really break down the training process, which is always a very complex part of machine learning, into a single config file that can be our single source of truth for everything. And given the same config file, you'll always be able to reproduce the same results. If anyone running that config file will be able to perform the exact same steps and use the exact same functions, which can also be provided on the command line. So that's the only kind of file you swap in. That's where you define any custom code. And given the same functions and the same config, the results should be the same. But if you want to do, iterate quickly and try things out, you can also overwrite things on the command line, which can be useful for things like paths that you might not want to have in your config file. But still, we have one file, one single source of truth, so that's pretty convenient. And we can also provide some cool utilities to help people get started with a config. For example, the init config command generates a starter config for you, given a pipeline that you want to train and some other settings. For example, you can say, hey, I want to optimize for accuracy. That's most importantly, in which case we can generate you a starter config that uses probably the modern transformer pipelines and architectures that might be a bit slower and definitely require GPU, but will give you probably better results. Or you can say, hey, I want to optimize for efficiency. Then we can auto-generate you a starter config that probably runs on your local laptop with a CPU only, might not use the latest state-of-the-art weights, but runs faster and trains faster. So that's usually the workflow you can use to get started. We also have a little widget in the docs where you can click through. That's all here in a nightly docs, so you can play with it. And that kind of gets over the initial start, because yes, with the config system, one decision we've made is everything is in the config. There are no hidden defaults. There are no secret things that get passed in somewhere. Everything is represented in the config, which means it's very large. But on the other hand, it means, well, everything's in there. So here's kind of how real-life workflow could look. You can use the SpaCy train command with a config to train a model, save the result to an output directory, and then you can use the SpaCy package command to turn that model that you've just trained the pipeline into a Python package. So that's another cool feature we think is very useful. We really rely on Python's native solutions there, which is packaging. And so then you have this artifact that you can pip install and ship and run in your environment. So that's how you can easily package a SpaCy model. And then, yeah, here that's how it looks. You get this file that's pretty much like anything else you download from PyPy. That's exactly the same thing. You can pip install it, and it will install the model in your environment. You can version it. That's the nice thing about really relying on the native tools there. You get all of that out of the box. And then, yeah, you have that cool package that you can use, and then you can ship it, you can load it, and you can use it as a part of your application. Yeah.
So another feature that we have set up specifically for this type of whole end workflow, like Ines was showing you, where you start off with maybe you want to train and then you package. Well, actually, if you think about the workflow of most machine learning projects, there's always more steps than that. So you've always got basically at least two processes that you're communicating between. You're going to have the training step, and then in a separate process, you're going to load back in those weights. And this is pretty much always going to be the case, because for any machine learning application, the whole idea is that you're going to run the training over a whole bunch of examples and crystallize that knowledge to load back in later. So there's always this inter-process communication sort of workflow. And in fact, usually you're separating out the work over many more processes than that. For instance, before training, you might go over the data set many times to build a vocabulary, or you might go over the data set to generate a label set that you want to use in your training. So there's always this kind of step of like running multiple scripts. And this is what, typically if you clone somebody's repo or start running somebody's project, there's always this set of steps to go through. And so if the repo that you're cloning is sort of well organized, maybe the steps are well documented and they've got a good set of conventions, but it's kind of up to everyone to sort of come up with their own set of conventions for this. So we wanted to have a set of conventions that the SpaCy ecosystem and community could use and rely on, and that would be a kind of standard way of doing these things. So we built a little workflow tool into this, which was inspired initially by the data version control tool, but we decided that we wanted to have a more stripped down version that was a bit easier to work with, that didn't introduce so many extra concepts that people would really adopt easily and give you a smooth path to working with it. So here's the kind of conceptual model of this. We have these project templates, which are these YAML files, and you can clone that you can clone somebody's project template, or one which you have done before, or your colleagues or something, and you get this local project, or you can start authoring it from scratch. And then the project defines locations of assets. So you can define those as URLs to many of standard storages, or just a local file just to document if the file's not publicly available, what that file should be. You can also attach a checksum to it. And then you can start running, you can use the run command to start running things. And each run command you're able to list the outputs of it, again with optional checksums and also dependencies. And so you're able to have a linkage with the remote storage so that if there's any outputs which are previously cached, which your colleagues have computed before or which you've computed before, you're able to pull them down and sort of get started with any intermediate artifacts that they say, you don't need to retrain the vectors, you can just use them from this storage, or you don't need to rebuild this vocabulary file, you can just build that from the storage. And we've tried to make sure that the indexing system for the remote storage is convenient, so that you don't have to constantly be reversioning things and worrying that if you're going to upload to the remote storage that you'll clobber some previous result. It all goes off, the things are indexed by the checksums of the files, so that you'll basically never have to worry about overwriting old state. And the concept of this is that you'll have a smooth process from the prototyping stage to something that you can actually be able to ship to production. So it's all basically scripted for you so that the same workflow that you're using in, like, while you're developing the project will basically give a runnable set of steps to somebody when they want to run it on the continuous integration or run it with your colleagues. So that it gets you out of that sort of sandbox mode where you know that you're not really ready to ship it to anybody and you're basically just experimenting yourself. We want to make sure that you're already kind of working on a path that will be the process that will work for the team as well. So here's what this looks like in the commands. So these are the steps which I referred to before. You can clone a project template from some example, and then you'll go into that directory. You'll run this command, SpaCy project assets, to fetch the data down. So that will download any data assets that are referenced there, and then you can start running a workflow or an individual command. And the whole thing's a self-documenting, which is a nice feature that we'll be getting to soon as well. So you can push, the SpaCy project push command will go over any of the outputs that you've listed and upload them to a remote storage. If you've listed a remote storage like an AWS bucket or a Google Cloud Storage bucket, it could be a SSH directory. It supports quite a range of outputs there. Also just a local file, if a local directory, if that's convenient, like you've got a network share mapped or something. And one of the features that we particularly like is that when you run SpaCy project document, it actually generates the README file that lists all of the commands and things so that, you know, when somebody goes to the GitHub repo, they see, you know, what's there and everything. Again, we want to encourage these sorts of norms and build toolings that, you know, really make the right thing easy and push people to, you know, have these sort of standard files that work well and everybody can kind of like read and rely on. So here's what the YAML structure looks like. To be honest, YAML isn't my favorite markup language, but it's quite the standard for this type of thing. We tried to stick quite closely to the YAML structures that people might be familiar with from tools like Azure pipelines or BuildKite or something like this. And overall, I think, like, you know, we're not using anything too crazy in the language and it comes together quite well. We also made sure that the SpaCy commands which read YAML read it all in safe mode, and we actually made our own little distribution of YAML to make sure that we wouldn't have any of the problems that YAML can sometimes introduce. So actually, I will diverge on this. Do people know what I mean when I'm talking about security issues with YAML? So if you write the most obvious YAML code in Python, like, you know, YAML.read, on an arbitrary YAML file, you're allowing it to execute arbitrary Python. So if you just download a YAML file and run the most obvious code that's there, you're allowing people to run any code that they want, which I think is not good. That's, you know, mostly people think of this like a JSON file or something, like it's just data, and you know, I think it's highly unexpected that it could be running code. So we've tried to make sure that, you know, at least in our executions of this won't occur. But it is something to be aware of in general. You know, you're working with this language. So yeah, as I mentioned, these are the data assets. You can point them to many different remote things, and the checksums are optional as well, so that you can make sure that your colleagues are getting the right version of the files that you expect. And you know, if you're debugging things, you can see, well, at least I know that it's the right version of the file because the checksums are there. And then the named workflows are basically just lists of commands where the individual commands are these things like this. So the help strings are used in the both in the command line interface and in the documentation that's generated. And then you can list the file dependencies here. So this is kind of like a make file. It allows it to, check that something doesn't need to be rerun, but it also allows it to calculate the uploads and downloads for the remote caching commands. So overall, in addition to the actual project templates, we've been trying to make sure that we have good integrations with a wider ecosystem of things. So that, you know, we can basically help the SpaCy community do these things in a standard way and, you know, that it's easy to integrate with other remote tools and services. So we have a nice integration with Streamlit that's been built. We've been working with the Ray team to develop use Ray for parallel processing and basically remote computing in general. So the parallel training features there I think will be quite exciting. Data version control is the tool that I mentioned before, is kind of the souped up version of the projects command. There's an integration there as well. If you're using that tool, the project command makes it easy to use that. And weights and biases is an experiment tracker. Prodigy is our annotation tool, and Fast API is a popular API framework that's developed by one of the team members at Explosion as well. So all of these things are, have good integrations already, and I think actually the project system will allow us to provide example projects for more and more integrations for other services and tools, so that we can, help the SpaCy community stitch together more individual pieces to build the projects that they need to do. So here's an example of the weights and biases integration. So this is just, you can write in your config file, instead of using the console logger, it will log to the weights and biases service. You could do the same thing for, I don't know, if you had a different tensor board or a different ML flow or something that you wanted to do. The API for this in Python is pretty simple, and then you end up with just the config syntax, which Ines mentioned before. And then the output of this is you're able to go to the weights and biases page and see all of the graphs and things to track your experiment runs.
Yeah. And maybe actually before.
Yep.
Here, one thing that's pretty nice about the config as well, in combination with experiment tracking, is the idea that, of course, the config is reproducible and describes everything about your training process. So for the weights and biases integration, we're actually logging everything. We're logging, you can't really see that here probably, but like it's logging by default all of your config settings, including even the registered functions. So, weights and biases, or like most of these tools, provides like insights into how do your different settings impact your results, what could be correlated, and that also will include the registered function. So if you're hacking around with some new batching function and suddenly everything tanks, you'll actually be able to see that. You don't even have to decide, oh, I'm logging that specifically, because that's all stuff that's kind of subtle and hard to catch. Or maybe you have a bug in the way you're loading your examples and dividing them up. That's the real stuff that happens. That's much more likely than some hyperparameter that could be a bit different. And here with the config integration, you'll see, okay, suddenly if I'm loading my data like this, everything tanks and is super weird. And hopefully this can help find these types of mistakes that are, actually quite common. And then, Matt just mentioned Ray. You probably want to talk about that because you're even more excited about this than I am.
So for Ray is a system for basically remote computing. It gives you a really good set of primitives for basically designing how a program will communicate across multiple workers. We've been working with the Ray team to develop a good parallel training system for SpaCy. We have a pretty good basically data parallel setup here, where parts of the model are set to each worker, and each worker is responsible for updating part of the parameters, and it's able to work asynchronously without blocking. And so I think that this will, it still needs a little bit more tuning, but I think that this will allow us to get good performance on a wide range of devices with a wide range of models, which I think will be pretty exciting. Ray will also be useful for inference as well as training. So it basically allows you to schedule the work from your laptop or from your local machine and command a wider cluster of machines, which I think really helps us act on the promise of SpaCy of doing like web scale processing and really easily scheduling jobs over large machines. So the Streamlit integration is actually, do you want to do this?
Maybe I should I also wrote that one. Yeah. So Streamlit, you might be familiar with that as well. It's a pretty popular tool you can use to visualize and build data apps interactively in Python, which is pretty cool and also aligns well with our kind of ideas of programmable developer tooling. And you can very easily build interactive SpaCy apps using our SpaCy Streamlit package. So basically that includes building blocks you can put together for the different types of things you might want to visualize and look at interactively. For example, a named entity visualizer, you want to type in a sentence, see what your model predicts. You want to compare different models. You want to see a nice parse tree. And you can do all of that very easily. That already exists even for the current SpaCy version. So you can download it, either use the full visualizer in your code, then you really only have a few lines of code to create your app, or you can also put it together and use it to build your own apps, visualizations, and even more complex tools. So I already briefly actually mentioned the components like named entity recognition, dependency parsing, and so on. And the way SpaCy has pretty much always worked, and the fundamental idea is we start with a text, and we do stuff to that text and transform it into a more abstract representation that really lets us access everything about that text, including what words are mentioned, how they related to each other. At any point in that text we're analyzing, we can go in and discover the greater structure. So some of these steps we might be performing are dependency parsing, so basically how are words related to each other, part of speech tagging, what are the word types, what's a verb, what's a noun. Entity recognition, what names, phrases, concepts are mentioned, like person names, company names. Text categorization, so what labels apply to the text. Is the text about sports, about politics, about something else? Entity linking, which is a new component, reasonably fairly new component we have in SpaCy, which is very cool, which lets us, on top of the name entity recognition, also link those mentions of names to a node in our knowledge base. So we know that different mentions of a company actually relate to the same entity. And even, maybe there's a lot of ambiguity there that we want to resolve, so we can really look it up and know that's the thing. Lemmatization, that's just discovering the base forms of words. That's more relevant in some languages, a bit less in others. Entity ruler in SpaCy, that's a component that lets you write more either pretty straightforward rules or a bit more abstract rules to define your named entities, because often you're actually able to express what you're looking for in a pretty straightforward way. And in SpaCy, the matcher engine lets you write something a bit like regular expressions, but on the word level. So you can say, hey, I'm looking for a noun that's this, followed by that type of word from my word list. So there's a lot you can express or you could use to augment your model's predictions to get better results. Sentence recognizer, you want to segment text into sentences. Again, that's in some cases easier, in some cases harder. There are lots of different strategies, so you can apply that. And of course, there's lots more, including components that you can write yourself that are applied to the doc object as it's processed, and that lets you find out more about the text. And so how do we represent that in our config system? Because as I said before, the config system is the single source of truth and really needs to know everything about what we're processing here. So here's an example of a named entity recognizer component. We define a factory, which is how to create it, again, similar to the registered functions. And each component typically also holds a machine learning model that actually does the prediction and that we can train. So in this case, we're again referring to a registered architecture. We're setting a bunch of hyperparameters and settings for that component. Also, our model has a token to vector layer that actually does the encoding, where we can, in this case, we're referring to a transformer listener, so a component that checks the transformer component that runs earlier in the pipeline and gets the encoding from that. And we can basically build up our model and the layers and the sub-layers bottom up and define them, which also means that if you want to customize something, you're not limited to what we ship in SpaCy. You can say, hey, I would like to use a different entity recognition model and play with that. Or maybe I want to have a very different encoding strategy or tweak some of these hyperparameters. So you can all very easily do that via the config system. And You can also source components from existing train pipelines, which is often something you might want to do because you already have a tagger trained and you want to use that. So you can basically refer to an existing pre-trained pipeline and say, okay, I want the tagger from that or the entity recognizer. And you can also choose which components you want updated during training. So you can say, okay, I want to freeze the entity recognizer and only update everything else to really compose these pipelines out of different components and maybe even different models that you've trained before. And yeah, here, of course, none of this would be as cool if you couldn't also really customize it from end to end. So we have a decorator that lets you register any function as a custom pipeline component. So you can basically do anything, extract anything, analyze anything based on the doc that travels to the pipeline. And fundamentally, all a pipeline component is a function that takes a doc, does something to it, and returns it. So it can be something really simple as like finding some mentions in there, looking for something in that doc, or it can be a lot more complex, which is running a model that you've trained on that doc, getting predictions, interpreting the predictions, and storing them on the data structure so that you can use them. And yeah, that's how it works. You assign it a string name so we can identify it and reference it when you add it to the pipeline, but also in your config. And given that code, anyone else running that config will have that same component available. And for a more complex component here, we have a theoretical component that lets you resolve acronyms in text. You can also really register your own factory with settings because you often want to have a component hold some state, and you often want a component to be configurable in different ways. So here we have that component. It always takes the NLP object, which you can use to access the vocabulary. It takes the name. And then here we have any custom settings that we come up with that you can pass forward to your component. And then that's pretty much exactly how also the built-in components in SpaCy work. And you can reference it in your config. All other arguments on the factory become config settings, so you can use the exact same mechanism. Here, reference the factory function by name and reference the arguments, and you also get all the cool type checking stuff for free. So if here we're saying that needs to be a Boolean, if you pass in something else, if you pass in a list, you will see an error that exactly tells you what's wrong and make sure that your settings are all consistent. So.
So yeah, the next bit of configurability and customization that I want to talk about is within a specific component, the ability to bring your own model and to define that in the framework that you choose. So, there's a range of deep learning libraries available. These days, a lot of people are using PyTorch. So actually, of the people here who use deep learning libraries, who prefers PyTorch out of this? Right, and TensorFlow. Okay, so and maybe soon there'll be a huge momentum towards JAX, or maybe there's tasks where people want to use XGBoost or scikit-learn or something like that. We wanted to make sure that people were able to use the machine learning library that they wanted to use for the specific task that they had, and so. In order to do this, SpaCy interacts with machine learning libraries via a shim or a sort of common definition, which is this machine learning library that we built called Think. And this allows us to kind of code to a neutral interface that allows people to bring their own framework. And in the models that we implement for this, we implement them directly as Think layers, but you don't have to do this. You can just use it as a wrapper instead. And some of the features that we're particularly excited about this is, in addition to the configuration, that we're able to make use of type checking and new type annotations in Python for this, and also functional programming idioms, which I think give a pretty neat way to work with these models. So as I said, the key feature is that you can wrap layers defined in other frameworks. You can even actually stitch together models that are implemented in multiple ones and have them backpropagate to each other. So you can have some layers that are defined in something like MXNet and some other layers that are defined in like PyTorch, and the model will learn to basically pass gradients between them, and ideally not even copy the tensors through this if the libraries support an array interchange format. So here's what this looks like in practice. So imagine here that you have a custom PyTorch model. In practice, these could be quite complicated, so we wanted to keep this simple. And all this is doing is creating one layer with things that you could easily do in a number of different ways. And the magic here is this PyTorch wrapper thing, which presents to SpaCy a wrapper that it's able to communicate with, a common API standard that SpaCy expects, and the PyTorch layer is the PyTorch model is contained within that, and so SpaCy's and the gradients will be, and outputs will be passed into and out of that, so that it's able to learn from the data. And you can configure this with the configuration system because we've added this into the registry. So you could do this with any PyTorch model that you wanted to create. You can set whatever parameters or settings are required for that, create it inside the function, or even assemble it from multiple function invocations if you want to separate it out and build it up out of constituent pieces, and you're able to use this in SpaCy to power any of your components that you want to do this sort of thing with. So this really allows SpaCy users to take advantage of whichever machine learning library or idioms that they want to use. So, so am I doing? Yes. Yeah, okay. So the other bit of developer experience that we've really focusing in on it with this, and I think this is a big part of the feature set with this machine learning library Think, is type hinting. So we've touched on this a bit, but this is a new feature that's in Python, and all of the types are optional. You have to run this extra layer to get type errors, or you get errors in your editor. And I think this is very powerful for machine learning because machine learning code is often quite difficult to test, and the machine learning runtime can take a long time to run. And maybe you're even developing on a machine a local CPU where you actually can't really run the full model easily. And this has posed a problem for machine learning developers. And I think that type-based validation or type checking can be a really powerful feature for this if it's used well. And so I think we've got some neat strategies for this. So in addition to the checking, it can also help a lot for readability. So what we do in Think is we have this parametric type here. So you can see here the model there. That's a type that's assigned to any layer, and it basically means that it's a differentiable model that's able to you'll pass something in and you'll get a prediction at the end of it, or an output. And it's parameterized with that input and output type. So here the talk2vec layer says, okay, that needs to be a model that takes a list of docs as input and outputs a list of floats 2D, where floats 2D is going to be a two-dimensional array type of the type float. So we've got a few of these different array types for different dimensionalities and very basic typing. So we distinguish integers versus floats, and we distinguish dimensionality of 1, 2, 3, 4, and many. So keeping it as an enumerable list of types helps a lot to avoid some of the more nasty syntax that you would have if you tried to make that fully parametric. And so what you're able to see here is you're able to just read this and see, okay, it's chaining together this talk2vec layer, and then there's this layer 1, which also takes a list, floats 2D, and outputs a single floats 2D array, and then the layer after that, you can see that that's transforming the floats 2D into a different floats 2D. And so from this, the function returns a model that takes a list of docs and outputs the final one at the end, so floats 2D. So you can read this and see, all right, I can see how the logic of this lines up. And in fact, the type checking here works as well. So if you tried to pass in a combination of layers that wouldn't wire together, for instance, if you had two instances of this type, so that it's, you're outputting a list of floats 2D in the first layer, and the next layer is expecting a floats 2D, that will be a type error that is displayed in your editor. So it will be underlined for you. Or if you're running the type checker as part of a CI or just on the command line, it will show that up for you and tell you that there's an error here. As I said here, these are the generic types. We have these custom array types like this floats 2D, int1d. There's a number of other custom array types for containers. So we have one for padded arrays, one for a ragged format, etc. The output of this is type checked. So here's a slightly more detailed look of how it's working under the hood. So the functional programming idiom that all of this is based on is that we will take what we're going to output from each of these functions is the output, and then a callback that will compute the backward pass. So the callback here is just going to take the gradient with respect to the output, and it will return the gradient with respect to the input. The function here is annotated with the return types, and if we get this wrong, so here, for instance, where our function annotation expects a floats 1D, but we're returning something of the wrong shape. So here it knows from this reshape that it's reshaped to 3 dimensions, not 1. Then we'll get this sort of error. So it says incompatible return type. That's what it got, and it expected that instead. So this type of error is, there's many types of errors that are common when you're developing machine learning models. And the type checking doesn't cover all of them, but even getting some of these out at the development stage and also documented for other developers who are reading the code, or you who is reading the code later, can be enormously helpful. So this, again, is like an example of sort of what this looks like if you're just using the layers from the machine learning library Think. And we have this optional plugin that to the standard MyPy. And we think that this is actually a pretty neat thing, that you can write these plugins for the type checker. And we expect that this is all quite early in the Python ecosystem, that there'll be this growing support and growing ecosystem, these plugins that will allow the type system to kind of expand its support over a few different areas. So here you can see the type of error that we get here. So the reduced max there is expecting some type of container, and the ReLU layer there is only outputting a single array, and so it's unable to make this combination of layers work. And so even before you run it, or even before you've run your tests, your editor can be telling you that you've wired together your components in a way that can't work. Okay, so yep.
So yeah, that was a quick overview of SpaCy 3. SpaCy supports train pipelines and general base support, meaning you can train your own models for a variety of languages that are always growing as well. You can now do multitask learning with modern transformer models like BERT, and achieve results that get close to what the current state of the art. SpaCy has always been one of the fastest libraries around for NLP, and it still is, obviously. And we have built-in components for tasks like named entity recognition, tagging, parsing, entity linking, and a lot more. And of course, you can also implement your own custom trainable components or rule-based components using the powerful matcher engine. So you can really use all these components and put together custom pipelines to solve your very specific business problems that often consist of many different parts of things that you want to analyze. And the new training system and workflow system really helps close the gap between just whipping up a quick prototype and shipping something to production. And of course, the one thing we're most proud of and most happy about is our awesome ecosystem of plugins, lots of cool tools and things you can use together with SpaCy, plug into your pipeline. And we're super excited to see what the community comes up with and what people are going to build with the new SpaCy 3. So, as I said, you can already install it from pip as SpaCy Nightly, which is our pre-release channel. You can play with it. We have very extensive docs already for the new version. It's all there, lots of quick start widgets and helpers that you can use to get started. And yeah, I hope you'll try it out and let us know what you think and what you build with it. Thanks.
So what do we do for time? Because there's no clock in here. So I had no idea how over time.
15 minutes?
Yeah.
But actually, we have 15 minutes.
Cool.
But actually, we have Q&A. We will
Yep.
have open the floor. Are you okay to stay?
Oh, yeah,
with the-
absolutely.
I thought it was,
Yeah. So guys online, if you have a
test
question, you
this
can
mic.
just unmute yourself and ask.
Yeah.
So Sean, who can hear the online guys? Are you going to relay that, or can the presenters
everybody
hear
in
us?
the room can hear you. But you can't hear me because I haven't got a microphone.
Hey, Brad.
Yes,
We can
we
hear.
can. It doesn't need to be relayed. We just heard the question, so it's all good.
Yeah, awesome, guys. Great presentation. Really enjoyed it. Glad it was 7 o'clock as well, because I got to listen in after the kids went to bed. I got it's really much more general question to what you guys presented on. Like, you started off with a research tool that was super useful, and you realised lots of other people wanted it. There's so much going on and coming and going, and you know, it might be weights and biases one month and something else the next, and this and that. I'm really curious how you guys decide kind of what to partner with, incorporate. Is that customer driven, or do you guys make the calls on what you like? I'm really interested in your philosophy of how you guys do that with speed and so much going on.
Yeah, so that's definitely a good question, and I think that we're in the same position as many of our users in trying to look at the ecosystem of tools and evaluate different things. And we also do this when we're adopting things ourselves. So one of the things that was really important to us with the integrations, and actually one of the reasons why the integrations are kind of coming in now a little bit more, is that we want it all to be in user space. We don't want anything that's like, sort of built into the library that we're, having as these hard dependencies. So for something like the weights and biases integration, we quite like their service, and we see that there's a lot of adoption from the community, and that would be the, sort of number one service like that people wanted to use. But the integration there is absolutely on the same footing as, any other service that people want to use that's similar to that. So we wanted to make sure that it kind of worked in that way, because, as you say, it doesn't actually. For many of these tools, there's a wide ecosystem out there, and we can expect that there'll be more cool things coming. So for some of the other things, the Ray integration was a little bit deeper, and for that one, that was one which I did make the call, having used Ray and having used similar tools like that I really liked the actor model that Ray provided, and I felt like it actually filled a need for allowing me to define the sort of semantics that I wanted to do to get good performance for parallel training and other things like that. So that was more looking at the specifics of that tool, and yes, the adoption of it was good, but I also just liked the design of it, and I thought it was correct, basically.
Yeah, also maybe to add to that, I think from our perspective as a developer tool, we obviously look for other tools that have a similar philosophy and are also very programmable and fit in. Like we don't want necessarily to integrate with stuff that needs a lot of custom work, but also that users can't program with. Yeah. So when we see a tool that follows our philosophy, of course it could be that either we're completely wrong about all our instincts and everything, which would be bad, but I'm quite confident about like us being at least often right. Yeah. And so if we're also right about that kind of call, then it all comes together.
And equally, there can be lots of situations where people want something more like the no-code type of style, but SpaCy's a little bit different, and so the tools which will have good complementarity for it will be also tools which are programmable in the same way, because that means that, people who are wanting that sort of thing will want the two together. So I think that there's, a natural, just whether things dovetail in that sense for, whether they match the philosophy and approach, basically.
Okay. So, can they? Okay. Sorry. Anyway, initially, thank you so much for SpaCy, because I think when I started my PhD in 2016, you have to, okay. SpaCy gave me a good stance where I could produce results really quickly for my supervisors, just to show that it works before doing anything else. So thanks a lot. Okay, so I used it from that time to now. I'm still using it for various things. So one thing is, now I saw that the linkage one. So in that, I'm just wondering, do we have to put the linkage, or is it pre-trained already? So can we train it on something that we want?
So the question is, for the entity linker, does it come with just a pre-trained model, or is the sort of expected use case that you'll train it yourself? So entity linking is when we're deciding about how central we want a trained model to be in the workflow for this. The key criterion that we're thinking about is whether it's an annotation style that's kind of that refers to language internal stuff, or whether it refers to the person's problem domain. So for something like part-of-speech tagging or dependency parsing, that's really facts about English or facts about German that don't depend so much on what the data is or what the problem is that you're working with. No matter what you're trying to do, whether that noun attaches to that verb or doesn't is just a fact about the language. And so that's something where it really makes sense for us to put the trained models as a central part of the workflow. There's other components like the text categorizer where there's no true text categorization that we can give you. That's not a fact about the language at all. It's a fact about what you're trying to compute. So the answer for entity linking is, I would say that that's definitely something where it's in the problem domain. It's not something which is a fact about language, how you want to distinguish the different, maybe in some domains it's vitally important that all of the different country offices of Ernst & Young are different entities. In other ones, people would find that bizarre, and it's like, well, Ernst & Young's an entity. So, it depends hugely on the problem set. So we have an example for linking to Wikipedia, but even linking to Wikipedia, which version of Wikipedia, which data dump, etc. So almost always we expect that people will be training their own entity linking models.
Yeah, I think there's some community project where I think on Wikidata, some of the more general purpose ones, but we still say, hey, named entity recognition, again, that's also something that's quite problem specific. How do you want to define your scheme? It makes sense to at least use that as the baseline. So we basically, that's also a big reason why we focused a lot on making the training process even easier and more flexible in SpaCy 3, because we don't want this sort of obstacle to be there of is there a pre-trained model? No, then I can't use it. We want it to be much easier to say, cool, I'll label also with our other ecosystem, our other tooling, our stack, label some data very easily, very efficiently, put a model in a loop, sit down for 2 hours, you have a data set to build your own prototype, train a model quickly using SpaCy, the config system, reproduce it, and you can build fully custom solutions. And I hope that there won't be, the availability of a pre-trained model will be less and less of a bottleneck going forward with better tooling. At least that's our vision.
Mm-hmm. We have another online question.
You need to talk to them.
Okay. Something from the room?
The throw to the online questions, did they actually hear that? Because I think you're not mic'd, right? So should we just ask, are there any online questions?
Okay.
Yeah.
A bit shy.
Ah, well.
So then I have to ask, where next? So you've had a really interesting trajectory going from traditional NLP moving into where we are now with the transformer hype train, which is charging forward. You've built here like a really interesting like ecosystem around the productionization and kind of keeping that audit trail through the whole process. Where do you see kind of your next branch out in this space, the next frontier for you guys?
So a thing that we didn't talk about very much in this is our annotation tool Prodigy, which is a commercial product which basically makes it easy for people to annotate data themselves, to train their own models and use their own tasks. And so I think that the move to transformers dovetails with the vision that we had for this annotation tool very nicely. And that's that, what initially before transformers and transfer learning, people had this concept that in order to train more and more accurate models, you would need vast web scale, crowdsource, like millions of data points, make the annotation as cheap as possible and per unit point and, basically move it all to the Philippines if possible. And we always saw that there was a huge problem with this, and that's that you need to iterate over the data as well as the model type. So when you're defining the problem that you're working with, a lot of the thing that you need to do to make it work is in the division of the models. So decomposing what your business need is into a set of models is actually where all the action is. And it takes some iteration of that to do. And you can't iterate that without, basically annotating. So the division of the problem into different machine learning problems changes how you annotate the data. And so we always had Prodigy as an annotation tool that's designed for, basically these small scale things, and you're able to scale it up, but it scales down very well to even an individual developer working with it. And so what transfer learning brings with this is that's the data scale in a box that's generalized across all of the different problem domains. So you don't need to scale the data for an individual problem so much, because you've got the general language understanding capability in the transfer set. And so we think that this sort of trend of saying, all right, well, we don't need much annotated data will continue. And we think the tooling that supports this type of workflow of, all right, we don't need to throw annotation over the wall will continue to accelerate. And we've had good uptake for Prodigy, and we've got a new version coming out that's built for larger organizations as well, that we think will be, help a lot of people too. So, you want to add to that?
I was initially just thinking with the transfer learning that you can also you kind of think of it as, you're hiring a new employee. What do you want to teach that person? Ideally, you want to teach them about the task they're going to be doing. You don't want to have to teach them the shared language. You don't want to teach them about the culture and the world, or you don't want to raise them. You just, want to have someone who knows all the basics and just needs to learn a specific task. And that's kind of how we see that. So the idea is also to maybe go a bit deeper into this idea of breaking down the problems, because that always sounds very abstract. But what this really means is, and what we're trying to enable people to do is to say, okay, you often have a business problem is very rarely something you can just predict end to end. Or maybe you could, but it's not very practical. You want to analyze text. You want to find out what is it about. If it's about this, extract certain information for our database, populate the database, and then maybe link it to other nodes we have in our knowledge base, and then make some judgment about what all of this means for something very, very specific, like, how well is our production line doing? Are our machines okay? Is there anything we can improve in the way we maintain our, the production of our plane parts or something? A lot of very specific stuff. And so, usually it's not something where you can just feed in the data and try to predict one vector of it at the end. Usually you want to try predict one part, evaluate that, predict another part, then at the end put that all together, and that also needs someone who knows about what any of this means. And the idea is, if you can start off with at least the knowledge about the language and the world, all you have to train on top of it is the specifics about the problem and put all the different parts together. And we're hoping that with our tooling, like Prodigy Teams, which is the upcoming project, that this will become a lot easier, and that's kind of what we're working on and focus on.
And I'm really excited to see that evolving of the SpaCy in this space. And I definitely start with download the wiki, have the wiki dump and tokenize. And I'm really excited to want to know a little bit more about the acronym, how customization. You know that in Australia is so many acronyms and very local as well. Today you go to Fremantle, they call Fio, and you can't find it in the, and also the challenge from industry to industry, they have different acronym. So do you mind to explain a little bit the feature of it? I'm really exciting to how to see, I can train something in Wikipedia and then I can apply to more the specific problem.
Yeah, so I think in general that a lot of the research uses Wikipedia because of convenience and also because the data is unencumbered from copyright. So I think from the academic perspective, it makes a lot of sense for people to sort of present this as a sort of neutral proof of concept. But that doesn't mean that the Wikipedia data is useful for any specific application. So it's quite normal that you almost have to start from scratch on like the domain data that you have, and then it'll have different constraints and things. For acronym processing specifically, I think that I do look forward to having better components for this. I think there are already actually a couple of components that users have developed for this, and it's definitely something in specific domains that we want to do better at. I think actually co-reference resolution handled at the same time as entity linking will help us basically build up these acronym knowledge bases that people can do. That's the sort of component that I'd be interested in, is having a component which you're able to give it lots of raw text and it's able to give you acronym databases as output. I think that that's something that would be very useful for a lot of applications. But I expect that you will need to put in the data, or at least the text data that you're working with, in order to get the results that are sort of specific to your use case and domain. Okay, any questions from the web? Or from the room, but I think
we've already hassled everyone in the room. Yeah.
Well, it's just that the web can't see us gesturing vaguely too.
I thought the web can see us. I don't know.
Actually, the web can see us, but it can't see.
The room, no.
Yeah. So anyway.
So I guess one more for me. So the natural language space is a very broad space, and it's definitely, I can absolutely see your specialization in there. But I guess there's a kind of growing realization that the underlying techniques are much more very widely applicable in many other fields. And so, do you see your library kind of growing out of NLP, or are you really going to focus very strongly on NLP going forwards?
So for the annotation tool Prodigy, we definitely support more media types, and we did that partly because we think it's very useful to have projects which occasionally cross over these different media types. We don't have immediate plans to build open source libraries that take on those different domains, but this is potentially interesting if we had a bright idea for just how a computer vision library would work. But partly this is because we haven't worked on so many computer vision problems ourselves, so we lack that spark of or frustration with why is everything not just the way that I expect it to be? So
yeah, I think for SpaCy, it's one thing that is also very important to us in general in the libraries we build is to define a very clear scope. I think that's very important to say that's what it does and that's where it stops. Even with Prodigy, the first release we had, the standalone version, we say it's a developer tool. It does not come with admin features. That's something we're going to do separately, and that's the defined scope. Same with SpaCy, we're saying, well, the user needs to know what it is and what it does and what it doesn't. And we focus on large-scale text processing, information extraction. That's the type of library that SpaCy is built for. So SpaCy will not morph into a machine translation library. We think that's that's very important to define that clearly.
Yeah, definitely. I mean, on a sort of personal note, the moment where I first gave up on Windows and decided to install Linux after, having programmed under Windows a bit and my supervisors all telling me to install Linux, was this moment when I installed the CD burning software and installed all my media associations because you don't, if you're a CD burning company, you want to become a media player because that's, then you can insert ads into the media things. So there was this constant land grab of everything trying to steal your media associations. And so I think of that all the time when I think of the scope creep that you can get in different projects. From a commercial perspective, it can be, really, attractive to invade a adjacent territory. But from a user perspective who is using these tools, it can be very frustrating when this happens. And so we, developing developer tools, we have this sort of alignment with the users and the same sort of taste as the users. And I think that, we want to provide products that are quality. And I think part of that quality is having that defined scope and, knowing its place and knowing what it's for. And, at some point, if you want it to be different, you make something else that's like a separate thing instead of, kind of constantly trying to invade.
Awesome. So, any final questions? Jack.
So this might be an awful question, so please bear with me. So I was thinking, it's really amazing what you just showed. So I was just thinking about your philosophy, all these cool these things you said, and I was thinking about GPT-3 as you do nowadays, and I was also thinking about T5, and so the text-to-text framework, and especially GPT-3 is kind of amazing. I was not sold on it, but now it's amazing zero-shot applications, especially in the code type of application where it generates code, and same T5 showed the big success of text-to-text translation. A lot of people have thought about the idea, or talking more about the idea of kind of using natural language almost to literally compile or write your functions now, and it just feels like it's very interesting because it seems like it fits very well into your philosophy, and it would be a really good type of starting point for beginners, but also leverage a lot of kind of interesting ideas around your philosophies and your frameworks. So, they're into about fields about prompt generators and prompt engineers. I mean, do you have any thoughts on that type of space and any thoughts long-term around that?
Yeah, so I think it's quite interesting. And, even before the T5, the line of work that I saw sort of pushing in that direction was from Salesforce research. So Richard Soher's group were basically pushing this line of thinking where instead of having these different supervised tasks, question answering is all we need. So you would have the question would be what are the part of speech tags of this sentence? And then the answer would be the part of speech tags, instead of defining part of speech tagging as a separate problem. And so the idea would be that everything would shrink down into we don't need to think about different types of problem definitions. We can just do everything as sequence to sequence. And I think this is all wrong. So the reason for this is that I think that, usually the frustration that we feel with these things is not often that we've got too many ways to control the output, or we've got, that it's all so hard. What's actually the problem is getting the computer to do what we want it to do, right? And so trying to define the output only by the data, I think, is actually quite limiting. It's actually really helpful to be able to tell it what shape of output we want or what shape of answer we want, and even to sometimes build in inductive biases about how we expect the model to learn things from the data. I think this makes it much easier to control the thing. So, I like to say that machine learning is programming with data. So you specify the behavior of the program with the data that you give it, and that's great. But it's also really good to be able to define a loss function and to define these other things about what you want. And, this really makes it a lot easier to input extra control to say, all right, this type of mistake can't be made, or these are guarantees that I want this sort of thing to learn. So I don't think that we'll want to give up on that way of working with models. I think we're going to continue to want to define them algebraically instead of strictly from data and do it sort of vaguely inductively. So the way that I see something like GPT-3 is a structure that is partly fit towards the constraints of what OpenAI want to do. So it's not so much the way that everybody else wants to work with these models, it's the way that OpenAI wants to provide them to people. because they say, well, if we want to hold all of the weights private and we want to open this up to, basically a certain category of user, then this is what that ends up looking like. But I don't think it's what people who are very invested in this type of technology and people who, organizations who see it as worth spending a lot of money to get a certain result, or even spending a lot of money to get even a slightly better result, will want to do. So anybody who cares about their chatbots, or anybody who cares about, generating ad copy that will drive clicks slightly higher on some internal platform, is going to want to invest in doing this as, even this little bit better. And even if it costs many millions of dollars to train some of these models and do it all themselves and have their own AI team, well, companies will do this because I think that there's enough value there that the cost-benefit analysis will work out that way. So I don't think that the industry will collapse into something where, there's only one interface that you present with this, and, everything's question answering, or everything's, just using GPT-3 that's been trained once by one person. I don't think that that's the way that it'll go. Yeah, thanks.
Okay. Any more? We're good. Absolutely awesome, guys. So really appreciate you coming in. Thanks.